Hello, students. Professor Piggy here. Today, we're diving into virtualization, and this topic matters because it directly affects cost, resilience, performance, and security in modern IT environments. When virtualization is misunderstood or poorly managed, systems become inefficient, fragile, and exposed, which creates ideal conditions for attackers to exploit weaknesses. Imagine a strong pig running a barn that houses many smaller piglets, each in its own pen, sharing food and space safely as long as the strong pig is not overloaded. Virtualization works the same way because success depends on properly sizing and monitoring host resources to prevent contention. For exam purposes, remember that resource contention is a real operational risk and not just a theoretical design concern. Virtualization is a technology that allows multiple virtual machines to operate on a single physical system. A hypervisor is specialized software that creates, runs, and manages virtual machines. The physical system running the hypervisor is the host, and the operating systems running inside the virtual machines are guests. There are two hypervisor types you must know for the exam. A Type 1 hypervisor runs directly on the hardware and is commonly used in production environments because it provides stronger isolation, better performance, and improved security, with examples such as VMware ESXi and Microsoft Hyper-V. A Type 2 hypervisor runs on top of a host operating system and is typically used for testing, learning, or development, with examples such as Oracle VM VirtualBox. Hosts require significantly more resources than typical systems, including multi-core processors, large amounts of RAM, fast storage, and high-speed network interfaces. Guests can be different operating systems running simultaneously while sharing those host resources. Consolidation increases efficiency, but it also increases the importance of capacity planning, performance monitoring, and change control. Scalability in cloud environments refers to the manual process of resizing a virtual machine by assigning additional memory, processors, storage, or bandwidth. This process often requires a reboot because many operating systems can only recognize new hardware resources during startup. Elasticity in cloud environments refers to the automatic and dynamic adjustment of resources based on workload through cloud monitoring and orchestration without requiring a reboot. Virtualization often provides strong return on investment when organizations have many underutilized servers. For example, workloads from 9 lightly used physical servers can often be consolidated onto 2 or 3 hosts, reducing hardware purchases, electricity usage, cooling requirements, and physical space needs. For the exam, focus on the consolidation logic and efficiency gains rather than specific cost figures. Thin clients are systems with minimal local resources that connect to a server to run applications or desktops. Virtual desktop infrastructure hosts user desktop operating systems on centralized servers and allows access from traditional computers or mobile devices, commonly through a virtual private network. Centralizing desktops reduces endpoint risk because sensitive data remains on the server rather than the device. Containerization is operating system-level virtualization that runs applications in isolated containers using the host operating system and kernel. This differs from traditional virtual machines, which include a full guest operating system for each instance. Containers use fewer resources than virtual machines because they share the host operating system instead of duplicating it. VM escape is an attack in which an attacker breaks out of a guest virtual machine and gains access to the host system. Because the host runs with elevated privileges, a successful VM escape can allow control over all guest virtual machines on that host. Keeping hypervisors and guests fully patched, using sandboxing, and applying strict hypervisor hardening are critical controls to reduce this risk. Incorporating zero-trust principles does not prevent VM escape itself, but it can reduce the impact of a successful compromise.
Beyond patching, sandboxing, and hypervisor hardening, zero-trust techniques such as microsegmentation can reduce lateral movement and limit blast radius after an attacker gains access. For the exam, understand this as containment and blast radius reduction rather than primary prevention. VM sprawl occurs when virtual machines are created without proper tracking, patching, or lifecycle management. Unmanaged virtual machines increase the attack surface and consume system resources, which can degrade performance or cause outages. Change management, inventory tracking, and patching policies must apply equally to virtual and physical systems. Resource reuse is a cloud risk where data or resources may remain on shared infrastructure after a customer finishes using them. This can lead to data exposure if secure erasure is not performed by the cloud provider. The primary mitigation is contractual and technical assurance that the provider securely sanitizes storage and other resources. Virtual machines are stored as files, which makes replication and recovery fast and efficient. Snapshots capture the state of a virtual machine at a specific moment in time and allow administrators to roll back after failed updates or risky changes. Snapshots are useful recovery tools but are not a replacement for full backups. To summarize for the exam, virtualization allows multiple guest systems to run on a single host using a hypervisor. Type 1 hypervisors are typically used in production, while Type 2 hypervisors are commonly used for testing and learning. Scalability is manual, elasticity is automatic in cloud environments. Containers are operating system-level virtualization, and strong isolation with proper patching limits VM escape risk. If this lesson helped lock in those distinctions and save your bacon, like and subscribe for more truffles of wisdom. And until next time, oink!